Courses in the cement industry. Present to you.
Here's an electrostatic precipitator. You get an idea of its size when we look over here, and you can see that there's a staircase or a series of staircases that go up the side of the ESP. So they're quite large, although it really depends upon the size of the power station. On top of the ESP, what you'll actually have is a transformer normally, but we can't see it here. See, we've got a cross section on this side. The exhaust gases from the water tube boiler, they're going to come in via our ducts into the ESP from this direction. The exhaust gases pass through a perforated screen, that's this metal screen here, and then they travel through the ESP until they come out on the opposite side. And as I mentioned before, they're drawn through by our induced draft fan, which will be mounted between the ESP and the flue gas desulfurizer. You can see that we've got items hanging from the top of the ESP. We've got an electrical insulator, that's this item here. We've got electrodes, which are the yellow items that you can see here. If I zoom in, you can actually see that the yellow items are long rods, and they hang down all the way down to the bottom of the ESP. You can also see there's slight bits sticking out the side as well. These are called discharge electrodes. I'll see if I can go down and maintain the view. You can see here we're going down, down, down. There's another one. But you can generally see that they go all the way down to the bottom. Either side of the discharge electrodes are collector plates. Here is one, here is another, here is another. The discharge electrodes and collector plates are actually what make the ESP function. The discharge electrodes have a negative electrical charge. The collector plates have a positive charge. We actually pass a DC negative electrical current through our discharge electrodes. This then creates an electric field around each of our discharge electrodes. As the exhaust gases pass through the ESP, and remember the fly ash is contained within the exhaust gas, the particulates, those bits of ash that are suspended within the exhaust gas stream, bits of dust, bit of oxides of silicon, aluminium and iron and stuff like that, they're going to become negatively charged. So we're ionizing those particles. The collector plates are positively charged. Because the collector plates are positively charged, we're using DC, positive electrical current. The negatively charged particulates are going to be attracted to the collector plates, which are positively charged. And the principle is known as electrostatic force. So those negatively charged particulates are being attracted to our positively charged collector plates, and they're going to become stuck onto the collector plates. When they become stuck on the collector plates, we're going to need to occasionally remove them in order that our collector plates can keep operating efficiently. We do this in one of two ways. We can have a dry ESP and we can have a wet ESP. A wet ESP uses water to clean the collector plates, a dry ESP does not. A dry ESP will actually use what's called a wrapping system, and what the wrapping system will actually do is hit the collector plates with a series of hammers so that the resultant vibration through the collector plate will shake off a lot of the dust and fly ash that's gathered on the collector plate. Now I know that doesn't sound very scientific because we're just banging the side of the collector plates so that the fly ash and other particulates drop off, but that's pretty much how the wrapping system works. The hammers used in the wrapping system are connected to an electric motor via gearing, and as the motor turns, the gears turn and the hammers then collide or impact against the collector plates. Once the particulates have been shaken or removed from our collector plates, they drop to the bottom of the ESP, they'll come out through these discharge chutes here and then into collection hoppers or onto some conveyors, and the particulates will then be discharged to a collection area or storage area. From there, depending upon your geographical location, you may be able to sell these particulates as a byproduct. The cement industry actually purchases the particulates and other industries do as well. You can only really do this though if there's demand in the area. If there's not, then you have to dispose of the particulates in another way, which is a bit unfortunate because then you're paying someone to take it away, rather than them paying you to come and pick it up. As I mentioned before, the electrical transformer that supplies the electrical current needed for our discharge electrodes and collector plates is usually mounted on the top of the ESP, so somewhere around where my mouse is now. Typically it's a hermetic liquid insulated transformer, so it will be full of oil or some sort of insulating liquid. It will take a voltage, maybe 380 volts or 6000 volts, increase it to 20, 30, 40, 50, 60,000 volts, depending upon the design of the ESP. And then we'll pass that AC electrical current to a rectifier where we create the DC electrical current needed by the discharge electrodes and the collector plates. And from there, as already mentioned, we will be able to ionize the particulates coming in so that they are negatively charged, and then they'll be attracted to our positively charged collector plates. The electrical insulators that I mentioned previously, such as this one here, are to electrically isolate the discharge electrodes from the structure of the ESP. We come over here, this is how you'll actually see the ESP when you look in from the top. It's actually undercover, but the exhaust gases will pass through the ESP and flow through it, as you can see down here, and you can see our discharge chute on the opposite side. I hope now that you understand exactly how an electrostatic precipitator
Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.